Hello students, in this lecture we will study about superscalar operation. Okay, a superscalar operation is a type of operation which is used to handle exception. Okay, so in the previous lectures we have discussed about data path and control considerations. Okay. So basically pipeline makes it possible to execute instruction concurrently. Okay, let's look at what do you mean by pipeline, and then we'll discuss about how the superscalar operation is different than normal operations, normal pipeline operation. Okay, so pipeline makes it possible to execute instruction concurrently. So several instructions are present in the pipeline at the same point of time, but they're in different stages. Okay, like for example, as we have seen in previous pipeline concepts, that when one program is or one instruction is performing an ALU operation, okay, then another instruction is being decoded and another one is being fetched from memory, like this. Okay, so instructions enter the pipeline in a strict program order. Okay, so here I am writing the same thing, pipeline. At the same time, it is in the pipeline, but in the different stages. Okay, if I1 in fetch, and sorry, if I1 in the write, then I2 in the executing, I3 in the decoding, I4 in the fetching, and another one is waiting, like this. Okay, so but in the absence of hazards, one instruction enters the pipeline and one instruction completes the execution in each clock cycle. Okay, if hazard will not occur, then one instruction completes its execution and one instruction enters into the pipeline. That means if we'll take, let for 4 stage pipeline, and we have taken 4 instructions, let me show. Let's take an example of this. Okay, it is 4 stage pipeline. When I was in executing, it means it's completed in 5th clock cycle, and at the same time let I2 is entering into the pipeline. Okay, and means one is entering and one is exiting or complete stage execution. This means that the maximum throughput of a pipeline processor is one instruction per clock cycle. That means in the let's in the fifth clock cycle, it is already executed. Okay, and it is continued, it is entered. So in one clock cycle, one instruction is executed. Okay, and in the 6th clock cycle, I3 will execute. In 7th clock cycle, I4. In 8th clock cycle, I2, like this. Okay, that's why I have written here that the maximum throughput of a pipeline processor is one instruction per clock cycle. It is maximum. Okay, minimum is something, if hazard does not occur, then it is the maximum throughput. Okay, one clock cycle, one instruction will execute. Okay, but to get better performance, we may need to process multiple instructions. Okay, or there is some extra approach which by which the processor will process multiple units to handle several instructions. Okay, or a processor have multiple processing units. Okay, like multiple execution unit, multiple fetch unit, like this. Okay, then if it will have this type of features, multiple units, then it can handle several instructions in parallel. Okay, in each processing stage, if we'll have two fetch unit, then at a time we can fetch two instruction. If we'll have two execution unit, then at a time we can execute two instructions. Okay, so with this arrangement, several instructions start execution in the same clock cycle. Okay, I will explain it with a figure later. So if you have uh, two fetch unit, then at the same clock cycle two instructions can be fetched. Okay, and the processor is said to use multiple issue. Such processors are capable of achieving an instruction execution throughput of more than one instruction per clock cycle. Okay, it means if we have two execute unit, then at a time we can execute two instructions. That means two instructions per clock cycle. Okay, if we will use three, like this. Okay, so they are known as superscalar processors. Okay, normal processors have the throughput of maximum one instruction per clock cycle, but in the superscalar processors it may execute more than one instructions per clock cycle. Okay, so many modern high performance processors use this approach. Okay. So the instruction queue, what is the difference in the previous pipeline operations and superscalar processors? It is instruction queue is introduced so that a processor should be able to fetch more than one instruction at a time. Okay, in the previous data and control consideration we have already discussed about instruction queue. Then from the instruction queue it will go to the instruction decoder. Okay, then it will access the control signals. Okay, so instruction queue basically it is filled with the instructions. Okay, like a queue structure, like this, like this structure. Okay, so that a processor is able to fetch more than one instruction at a time. So for superscalar operation this arrangement is essential. Okay, there must be a instruction queue, and multiple issue operation requires a wider path to the cache and multiple execution units. Okay, as we have discussed about here, the processor used to multiple issue. So to achieve this multiple issue we need multiple execution unit and multiple path to the cache, so that we can achieve more and more uh, cache. Okay, you can easily access the cache. Here is one example in which separate execution units are provided for integer and floating point instruction. Okay, we are executing two instructions, one for fetching and another one for integer. Okay, the two types of instruction we are executing. So it is instruction fetch unit. Okay, so in this first instruction fetch unit will fetch the instruction. Okay, then it will store in the instruction queue. Okay, this is the first instruction, this is the second instruction. Okay, so it is go to the dispatch unit. Okay, and then there is two execution unit. Okay, so it is in the buffer. These are interstage buffers, as we have already discussed in the hardware unit, that in every unit, every stage there must be a buffer. Okay, so dispatch, then from dispatch unit it will go to their respective execution units. Okay, in each clock cycle the dispatch unit retrieves and decodes up to two instructions from the current queue. Okay, so in this type of processor the dispatch unit can retrieve and decode two instructions. Okay, if there is one integer, one floating point instruction and no hazards, you have to remember that no hazards, both instructions are dispatched in the same clock cycle. Okay, so in the superscalar processor the effect on performance of various hazard becomes even more and more. Okay, so what will happen in this way, the compiler interleave the floating point and integer instructions. Okay, and this also enables the dispatch unit to keep both the integer and floating point units busy most of the time. Okay, so these are the hardwares. Dispatch unit can dispatch two instructions, and for execution we need two unit. Okay, and in the first unit it is for floating point unit execution and it is for integer unit execution, and both are written in the memory location. Okay, so this is a diagram of any processor with two execution unit. Okay, that is the instruction queue, and to get rid of more issues, we are using two execution units. Okay, so let's see how the instruction will flow in this type of processor with assuming no hazards. Okay, so what I have told you, I have written here. The instruction fetch unit is capable of reading two instructions at a time and storing them in an instruction queue. In each clock cycle, the dispatch unit retrieves and decodes up to two instructions from the front of the queue. Okay, if there is no one integer, one floating point instruction, and no hazards, both instructions are dispatched in the same clock cycle. Okay, so it is the condition. Okay, if one is integer and one is floating point, and both are also independent on each other, if dependency occurs, then hazard will occur. Okay, so you can easily dispatch or decode both the instruction in the same clock cycle. Okay, so this is a diagram. Okay, so this is a pipeline timing diagram. Okay, so these are the floating point units, and here is the floating point addition, floating point subtraction. Okay, so the floating point unit takes 3 clock cycles to complete the floating point operation. Okay, in the I1 we have draw it, and the integer unit completes execution. It is for integer, it is for floating point. Okay, integer unit completes execution in I2 in 1 clock cycle. Okay, but it is needs 3 clock cycle. We have also assumed that the floating point unit is organized internally as a 3-stage pipeline. Okay, thus it can still accept a new instruction. Okay, so if this will occur, then instruction I3 and I4 enter the dispatch unit in clock cycle 3 and both are dispatched in clock cycle 4. Okay, it is enters to the dispatch unit, the decode unit in clock cycle 3, and it is dispatched means exit this dispatch unit in the clock cycle 4. Okay, so the integer unit can receive a new instruction because instruction I2 had proceed to the right stage. Sorry, it is right. Okay, the right stage. Okay, so instruction I1 in still in the execution. Okay, but I2 in the right stage. Okay, so instruction what it will do, it has moved to the second stage of internal pipeline in the floating point unit. Okay, so therefore instruction I3 can enter into the first stage, assuming that no hazards in the encounter. Okay, so the instruction will complete its execution. Okay, as it is in the execution unit, so we can easily fetch the I3, and as this I2 is in the W means in the right stage, then also this next integer instruction can also be fetched. So these two instruction is fetched at the same clock cycle, and these two also at the same clock cycle, and in less number of clock cycle we can execute more number of instructions. So this is one type of superscalar operation.